we are talking about adding and subtracting algebraic fractions. Now, the aim of the lesson is to be able to employ various factorization techniques to add, subtract, and then simplify algebraic fractions. Now, before I do anything, let's have a look at something like half plus 1/5. In order to do that, you need to know that we have to bring this to the common denominator, which means I have to multiply 2 by 5 to make it a 10 and make sure that I've got a numerator of 5. Alright, in this case, the 5 over 5 is actually 1. I'm not changing the value of half. The value still remains as half, but I'm changing the appearance of it, that's all. And then, of course, the 1/5. I am multiplying the denominator by 2 to make it 10 and the numerator by 2. So therefore, we now have 5 over 10 plus 2 over 10, which is 7 over 10. Now, we need to realize that we can change the value of the appearance of a fraction by multiplying with 1. And 1 can be something like 5 over 5 or 2 over 2 or maybe x over x or something like that. Alright, this is how to bring the fractions into the same denominator. Now, just representing it in terms of pronumerals or variables, let's consider two fractions, a, b, and c over d. We need to work out a over b plus c over d or a over b minus c over d. So, we should express both fractions with common denominator, and in this case, the common denominator is b times d. So therefore, to convert ab to a denominator of bd, we need to multiply a over b by d over d. Same with the case of cd. If we want the denominator to be bd, we multiply c over d by b over b. Again, notice that these are actually 1. Alright, so therefore, we can see that a over b plus c over d is actually ad plus bc over bd. Same with this, minus ab minus c over d equals to ad minus bc over bd. Alright, let's apply this to some example of algebraic fractions. First, we've got 3 algebraic fractions here. You know that 1 has got a denominator of 2, 1 has a denominator of 5, and the other one has a denominator of 10. Therefore, we know that the lowest common denominator is actually 10. What we can do in this case is multiply the first term, x minus 1 over 2, with 5 over 5, because we want to change the denominator to 10. And the next term, x plus 3 over 5, with 2 over 2, so that we can change the denominator to 10. While the third term, we do not have to do anything at all. We keep it as 10. Alright, multiplying 2 by 5 is 10. We can rewrite the numerator as 5 into x minus 1, so that we can use the distributive law. Same with this one, the numerator is 2 times x plus 3 over 10 plus x plus 7 over 10. Alright, therefore, writing everything with one common denominator, 5x minus 1, expanding 5x plus 1, plus 2x plus 6 plus x plus 7. Therefore, that equals to 8x plus 8 over 10. And we can actually simplify this by taking the 4 out. X plus 2 over 10. And therefore, we can cross out. This is 2 and this is 5. Therefore, it's 2x plus 2 over 5. Now, there's actually another way of doing it. 8x plus 8 over 10. We can actually Just cancel it. 8 divided by 2 is 4. 8 divided by 2 is 4. 10 divided by 2 is 5. And therefore that becomes 4x plus 4 over 5. I'm happy with both answers. You can actually give the answers either here or this one. They are both correct. Now, let's go to the next level. In this case, I've got the denominator for the first term as x minus 1 and the denominator for the second term as x plus 2, sorry. So now we know that the lowest common denominator, if this is b and this is d, is actually minus x minus 1 times x plus 2. So therefore, what we need to do is the first term of x minus 1, I'll put a bracket in, is multiplied by x plus 2 over x plus 2. Again, you know that x plus 2 over x plus 2 is actually 1. Minus 1 over x plus 2 times x minus 1, x minus 1. Alright, therefore, we now have the denominator x minus 1 and x plus 2. And then, for this term is 6 into x plus 2 and minus 1 into x minus 1. We now have 6x plus 12 minus x plus 1 over x minus 1 times x plus 2. Collecting like terms, 6x minus x is 5x, 12 plus 1 is 13 over x minus 1, x plus 2. You don't actually have to expand the denominator, just leave it. Right, the next one, I want you to think about it. Pause the video for a while and think about what you can do. Here, we can see that the first term, the denominator is x minus 2 times x plus 1. Second term, the denominator is x plus 1, x minus 3. So you can see that there are three different brackets in there, x minus 2, x minus 3, and the common one is x plus 1. So therefore, we can say that the common denominator is actually x minus 2 times x plus 1 times x minus 3. Alright, so let me write it here. We've got the first term 2, x minus 2, x plus 1 multiplied by x minus 3, because this term does not have an x minus 3. So now, next term, x plus 1, x minus 3. Alright, multiplied by x minus 2, x minus 2. Then, we can write the lowest common denominator as x minus 2, x plus 1, and x minus 3. Alright, so this term here will be 2, x minus 3, plus 5, x minus 2. Therefore, expanding the bracket, for the numerator we have 2x minus 6 plus 5x minus 10. Denominator still stay the same. I'm actually not going to expand it. X minus 3. Therefore, you now have 7x minus 16 over x minus 2, x plus 1, and x minus 3. Right, the next one. Think about this for a minute. Are we going to multiply c squared minus 3c minus 18 with c squared plus 5c plus 6? I don't think so. Let's have a look at the denominator. Alright, c squared minus 3c minus 18. Can you factorize it? In fact, you can. It actually becomes c minus 6 and c plus 3. And what about the next one? C squared plus 5c plus 6. That becomes c plus 2 and c plus 3. Therefore, you can see that there are common c plus 3. So rewriting this I'm going to write down 4, c minus 6, and c plus 3, plus 2, c plus 2, c plus 3. So using the same principle as the previous example, I now have 4, c minus 6, c plus 3, times c plus 2, and c plus 2, plus 2, c plus 2, c plus 3, and times c minus 6. Right? So we can write the denominator as c minus 6, c plus 3, c plus 2, and 4c plus 8 plus 2c minus 12. And therefore, the numerator becomes 6c minus 4, and the denominator is the same, c minus 6, c plus 3, and c plus 2. Alright? Now, I'm going to show you the last example. Alright, let's have a look at these algebraic fractions. Now, this one looks a little bit complicated. Let's have a look at the first term. Can we actually simplify the numerator? I don't think so. What about the denominator? The denominator is x squared minus 16y squared. And you can write this as x squared minus 4y all squared, which means you have a difference of 2 squares. Then you can factorize it as x minus 4y and x plus 4y. The second term, 2xy, you cannot actually simplify it, whereas 2x squared plus 8xy, you can actually factorize it by taking out the highest common denominator, which is 2x, x plus 4y. Alright? So therefore, rewriting the whole algebraic expressions, we now have x squared plus 5xy minus 4y squared over x squared, x minus 4y and x plus 4y, alright, minus 2xy over 2x, x plus 4y. Right, so we can actually cancel the 2x. Now we know that in order to have the lowest common denominator, we need to multiply the second term by x minus 4y over x minus 4y. Therefore, rewriting everything straight away, x minus 4y, x plus 4y, we now have x squared plus 5xy minus 4y squared minus y times x minus 4y. Alright, so therefore the numerator now becomes x squared plus 5xy minus 4y squared minus xy plus 4y squared divided by x minus 4y, x plus 4y. Right? So now you can collect like terms. Minus 4y plus 4y squared, that becomes 0, plus 5xy minus xy is 4xy. So x squared plus 4xy divided by x minus 4y, x plus 4y. Right. The next thing we really need to think about is, can we simplify this expression more? We can, if we factorize, taking out common factor x, this will be x plus 4y for the numerator, and x minus 4y and x plus 4y for the denominator. Now we can cancel this off, which means the whole expression is simplified to x over x minus 4y. That's it. That's the end of the lesson. I hope you have learned some techniques in terms of adding and subtracting algebraic fractions.